Okay, good. So yeah, as as Dennis mentioned in his talk, I'm a senior software engineer at Cornelis Networks. Mostly work on Libfabric and user space. So the OPX provider, I guess, is probably best viewed as the user space part of the device driver, kind of a user interface into the hardware. So here's the mandatory intro slide. So if these slides look familiar, it's because I stole them from Dennis and copied them. So thank you, Dennis. So for those that don't know, Cornelis Networks is a company that it was started as QLogic, and earlier it had different names. It was bought by Intel. The Omni-Path product was released when we were part of Intel, and about 3 years ago, I think we spun out of Intel and are working on some of our own products now. OPX is basically OPX started as an experiment where the BGQ Libfabric provider was cloned, and then kind of the hardware specific stuff ripped out of it, and it was recoded for Omni-Path hardware. It wasn't the Blue Gene Q hardware was a lot different from the Omni-Path hardware, so certain things had to be filled in there. And I kind of found myself thinking like, well, Dennis was talking about copying the QIB driver and all that, and it's OPX started out that way too. And there's it's always coulda, shoulda, woulda, but it was you got to have some place to start, I guess, and that gets you there faster than anything. So that was some background. OPX has been upstream for about, I think, 2 years now. The alternative is PSM2. So you have 2 different providers in Libfabric to run the same hardware with the same device driver, which is kind of nice. So in the past year, kind of wanted to present some of the things that we got done since the last time we presented at the OFI conference. The biggest thing is we did get there's on our hardware, there's 2 methods to send and there's 2 methods to receive. And like most networking hardware, it transmits faster than it receives. So the second transmit method kind of gives you a bit of overlap when you do like a bulk data send. So there's one transmit method that works good for smaller messages, and one for larger messages where you can kind of get off the core and kind of let the hardware deal with it in the background, which works pretty well. But if you let it go too fast, it'll completely overrun the receive interface unless you have all of that implemented as well, which in our case would be the RDMA part of our hardware. So that part has not been implemented, or it hasn't been upstreamed yet. But the sending interface has been. There's been a couple of additional Libfabric type of features to make the provider a bit more complete were added. One of them is auto progress, which for Libfabric, the progress model, it kind of involves the middleware or the application kind of participating with the provider to call it and say, hey, now would be a good time for me to get data. Is there any for me to get? And so that would be the reading your completion queues in through OFI, and when the middleware participates in that, it works a little bit better. It's a little bit better of a semantic match. So the manual progress mode for OPX tends to be faster than the auto progress mode in almost every test that I've tried it in. And it just it works that way because the auto progress mode spawns off a thread and just calls CQ read, even though they don't care. There might be a TX only thread, like OpenSHMEM or something like that, just doing transmit. So you have to, since we have our own reliability and it's an on-load model at the current time, we have to actually receive messages for them, even though they don't think they're receiving messages. So it's so auto progress does work. We have that implemented, but with OpenSHMEM, it still seems to be not as performant. The other feature we added was AV table, a different addressing mode, which probably most MPI people aren't going to care that much about. It works, and it probably doesn't have much effect on. It does seem at scale maybe AV map might be a little bit faster, but I'd have to have some testing to prove that. One other thing that we did fix that was a problem when we started testing apps at scale was that we discovered that our tag matching, we had a key. So there's an MPI requirement. If you have an ambiguous tag match, like if the receiver, the RX side post receive buffer that could match multiple tag messages, you have to match those in the order that you received them on the wire. So that means that we have to queue up unexpected messages and preserve the order of arrival. So we were doing that just with a simple queue, and that gets you pretty good performance up to about 800 or 900 messages deep. But after that, you see it, O to the n squared complexity, you rapidly see it diminish. So what we did is we added kind of a spillover hash table that, we hash it out in buckets based on matches. And, it seems to perform, kind of scale like linearly after you hit a certain amount. So that was a big problem at scale that was fixed. Another thing that we're pretty excited about is Deos. We've been testing OPX and doing development with Deos for about 1.5 years now, at least. And there's an upcoming release of Deos 2.4, which will include a Libfabric with OPX in it, and Deos should work over Libfabric with OPX. And that was actually a pretty interesting project because Deos has it's an HPC object store, but it has kind of almost like enterprise type, it almost reminds me of like Fiber Channel a bit in terms of like enterprise level reliability requirements, where like if you have a server crash and you have some packets floating around in the fabric that server wanted to get, another server will really quickly boot up and kind of steal his address and say, hey, I'm, every packet that was sent for this server that crashed, you can give me those. And that server will, get all the data that's floating around in the fabric, so you lose less. So that's kind of a neat requirement, or a neat thing that one of the things that Deos will do. There was some changes for reliability. Obviously, testing at scale, you find different bugs and different tuning knobs. I mean, there's so many tuning knobs that we, a lot of times we'll sharp define them in C, but it's tempting to expose them to users, but it's how many knobs do you expose before the user? You just give them so many different tuning things to test that it just becomes a really hard thing to tune. So so that's we have to be careful when we expose tuning knobs in OPX for just to keep it usable. We made quite a bit of progress with OpenSHMEM. There's been a couple of patches actually upstream where OpenSHMEM actually supports manual progress with OPX now. I believe that's upstream, and it seems to perform better than the auto progress. The observability is an interesting, we're starting to, as we test apps at scale, we're starting to see like, well, this app is hanging, but is it a bug in OPX or the driver or hardware, or is it in the app? And so you actually end up debugging the app quite a bit. And so there's some usability things in OPX that we can tell application developers. I mean, they're hard to get right now. We have to make observable a bit more user friendly. But if you had like if you had 1,000 endpoints and you're hung, and you have like one endpoint that had 2 unmatched unexpected messages, and all the other ones don't have any, well, that's probably some pretty interesting information that an app developer would like to know if they're chasing their own bugs. And we have this information sitting in OPX, but how do you get it to the user so they can see it? That's we have some ideas for that, and hopefully those get upstreamed pretty soon. So we're pretty excited about that this year. This is a bit of a summary of the change to OPX since the last time we presented at the OFI working group. You can see the bulk transfer added quite a bit of performance at the higher messages, which is it's good to see. We couldn't quite hit line rate with just PIO, but it was actually pretty amazing how close we could get with it. So this is also not showing any of the more recent RDMA work that we have. It definitely changes this chart a bit, but that hasn't been upstreamed yet. Yeah, things in progress. The biggest one is going to be RDMA. It was really good hearing some of the other talks talking about trying to use RDMA and hearing them, running into kind of some of the same issues that we're seeing. I mean, it's the RX side for RDMA. It gets interesting, especially when you run for a while and you start having, if you map, a user buffer and then you map another one over here and they post another receive, like, it costs you a lot of money to pin and or a lot of time to pin and make these system calls to get all this memory set so that the Linux RDMA subsystem is happy with them. You have to make the kernel happy first before you can use them. And so we have to do what it amounts to is on the receive side, we have to try to do caching of all of these pinnings and the way that we have these RDMA buffers mapped. And obviously that adds a lot of complexity to the provider, but and we're tuning it right now, but it definitely does pay off when it works right. And different apps using RDMA posting buffers in different ways, it definitely changes the performance characterizations of it. So we're focusing on apps and trying to make it as fast and usable as possible. I think I already talked about Deos support a bit. Actually, yeah, that was some interesting. We had to do for our intranode shared provider. OPX implemented a multi-producer, multi-consumer lock-free queue for intranode performance, for performance intranode IPT. And we actually had to change it a bit to make Deos work correctly with it. So it kind of makes it, the Deos requirement kind of makes usability of other parts of providers, it's a challenge. One of the newer things is the GPU support. The HFI1 driver has had some changes recently to change how we, when we're trying to do RDMA with GPU memory, how that works, and we're enabling that support in OPX right now. So it's on the way and it should be upstreamed soon. The first thing that we're testing with is CUDA, but there's other interfaces to follow as well. It quickly, I mean, when you want to start talking about upstream first, I mean, adding, supporting different, GPU backends and different, Deos or no Deos and all of these kind of configuration complexities, they really, I mean, you want to upstream things as fast as you can, but, look at the testing matrix of all of this stuff. I mean, you can't, if you upstream GPU support, you don't want to break message support, right? So you better test it and not just upstream it with just testing GPU. So you have to maintain quality and usability. You definitely have to test the stuff that works quite a bit. So let's see. Yeah, we have the CN5000 product is in flight, and there should be some changes for that coming upstream soon. And then the ones that I'm excited about is the observability and debugability changes that we'll have coming soon, which hopefully help users with their problems on our using our hardware to figure out some of their problems. So I'll just fill these in. This is a slide that I stole from Charles Shereda. That was presented at SC last year. This is kind of a good graphical representation. I didn't want to have anything too specific about line rate on here, but this is a good graphical representation of one of the ways that you can choose the send method and the receive method to a certain extent is that a lot of providers will first look at the message size. How big is it? Is it really small? Is it a few bytes, or is it a few meg, or is it a few gig? and that's going to obviously choose, you know, which path you go down. Basically what we've done in OPX, I mean, as you can see, it's mostly eager, which is the first part of the hardware that I talked about earlier, up until you have to start doing rendezvous. At which point rendezvous, you have, you know, a couple of different methods on it, and really you can't shoot on the hardware fits into the rendezvous protocol really well, because on the send side, you send a ready to send, and the receive side, you look and see like, well, what's the ready to send look like? What kind of resources do I have for RDMA? What kind of resources do I have for, you know, eager receive, that kind of thing. And then the CTS kind of comes back with a plan of how to send that data, you know, however big it is. Maybe it's just a couple packets, or maybe it's, you know, several hundred packets. So that's, you know, that's pretty standard behavior right there. And we start doing that around, you know, a bit over 16K right now, but that's an arbitrary tuning limit, where we'll switch from multi-packet eager into rendezvous. So wanted to echo some of Dennis's point earlier, because yes, upstream first is a good way to be, you know, get it out there in the hands of users, and don't have these huge, you know, 15, you know, change, you know, pull requests coming in upstream. And really, you know, like Charles said earlier, it really amounts to us, you know, just really wanting to test a lot more of these changes before we, you know, give them to the community, just trying to provide a bit more quality there. But we're still fine tuning the process, and you know, like we said earlier, we're trying to get to a cadence where our development sprints are a month long, and it'd be nice, you know, in concert with a development sprint, to have, you know, changes going out about every month or so. And I think we'll get there eventually. And in terms of testing, there's, you know, we have, you know, several automated test systems inside Cornelis Networks, but there's some testing that's, I'd say, a bit more, I guess, artistic, that it doesn't automate well, and it's a bit harder to do. OPX is done in a design by contract type of way, where we enforce contracts with asserts wherever possible, and you only get those in debug builds, which I wouldn't recommend in any production ever run a debug build. But for us, they're useful for finding bugs and extended testing, and you know, some of these tests kind of tend to you know, go into like a developer specific build, and doing, you know, extended testing, where you, like, say, intentionally drop packets, you know, at certain points, and things to make sure your reliability is working, you know, things like that are not easy to automate testing. So it's kind of a challenge, I guess, to upstreaming things really fast, if you want to be diligent about testing. So I guess another thing is scale. I mean, to some people, you know, 8 nodes is a lot, but to other people, 64 nodes is a lot. So, you know, if you test at scale, like what's full scale, you know? So I wanted to have kind of a current status of observability slide. Earlier, there was a good point made, I think by Amir from Prey, who was talking about, like, you know, selecting, you know, you have this like GPU and HFI, and then you know, like maybe 3 different NUMA domains involved in like one HPC rank, you know, depending on what hardware they're using. So it's really, and then with, you know, a lot of the newer hardware, especially chiplet based design, you know, compute nodes, you tend to get a lot of NUMA nodes. And then you change some settings in the BIOS, and you have even more NUMA nodes. So you know, it's different, you know, even more complexities to test if you want to be thorough about testing that. So, you know, how do you tell a user, like, well, you know, a lot of times you can't say, I want the most optimal GPU on the most optimal HFI on the most optimal, you know, core, right? Which would, you know, some some ranks in the node will be that much, but some ranks aren't going to be that lucky, and they're going to be a bit farther away in the memory domain from what they're working with. So a lot of times, we see like with queuing, there's head of line blocking problems when that happens, and other things. So it's really, it gets complicated really quick. So just kind of looking through the observability now, some of the logs that we have here, the intent would be without a special debug build, with just what you get right from Libfabric, from Unigster or whatever. If you set by log level info as a user, there's a lot of Libfabric specific things in there, but there might be some things that are user, that the HPC user might care about. And one of them would be like say getting warned that you're not running, that there's say a more optimal NUMA configuration. Like let's say, for whatever reason it chose this GPU and this HFI. If we were to check and say, well, there's slots open for other things, and tell somebody, hey, this could have been more optimal if you would have chose HFI 1 instead of HFI 0 for this rank. Because otherwise the logs get a bit chatty, and you don't want to be cutting warnings for, if you just, if the NUMA domain is slightly slower than the optimal one, it's probably not worth warning them about it, because you'll be warning them all the time. But if there is something that, for sure that they could have done a lot better with, you definitely want to give them a nice hint in the form of a warn in a log like this. So, that's one just kind of small specific example. The logging in OPX is still very verbose, almost like almost bring up level, really in terms of its verbosity, and we don't want to lose a lot of that, but a lot of times we don't need that much either, especially after we've tested it enough and it's really solid and we've upstreamed it. A lot of times we don't need those super verbose logs anymore, but you don't want to lose them either. So because in the future you never know. So we're going to have to take some of the logging out of there, I think, because it's just, if you let it run at log level info right now, it'll create quite large logs in a little bit of time. So the goal with this, with the user, opening up observability to users, is going to be, hey, you can run an HPC job for days with log level info, and it won't, fill up you won't generate this huge, terabyte long text file. You don't want to do that. So that's kind of tailoring into debugability. The logs would be kind of the main part of it, but there's also some other, there could be some other information that we use, especially when it comes to some of the newer routing algorithms, like non-optimal routing. How helping a user debug, like performance slowdowns and application jitter, when you have these more complicated flow control mechanisms, to kind of know like when the hardware is kicking in and doing flow control. Exposing that to users would, I think, help in a lot of situations. There's a lot of things that I think users are interested in there that are kind of for the eyes of Libfabric developers only right now, and the goal is to open that up a bit. So I guess with that, I'm a bit early, but that's pretty much all the content I had for my slides. I don't think I missed anything.
Cool. Thank you.
I think I lost my WebEx control. I can't see what's going on.
We see your thank you slide.
Okay.
Yeah, it's sometimes hard to figure out how to unshare on WebEx. Do we have any questions for Tim? Don't see any questions on chat. It's a nicely comprehensive